So in this video, it's all about the prerequisite of learning how to find the volume of certain solid. Please recall this problem. If I ask you how to find the area of the shaded region below, and can you tell me something about that? Let's say that you are given the function f of x for the curve y equals f of x now. So let me know the formula now. So the area formula is gonna be the integration from a to b for the function f of x, right? And there's something you must have learned previously in some previous chapters in calculus. And I would like to informally give you some conceptual understanding of this formula because it's going to be very beneficial for you in the future when you try to learn how to find the volume of a solid, which is a three-dimensional figure. And now in this case, the area is the quantity of a two-dimensional figure. So basically to find the volume, and we need to really informally understand the integral sign here. So please recall this kind of thing in terms of computation is called definite integral. And the fact is that you can try to think about it informally as below. The reason why this formula helps you find the area is that you can think of the integral sign as sum of something from x equals a to x equals b. So that's a very informal introduction, and obviously if you want to learn it formally, if you go to the calculus textbook, this one is called the Riemann sum. And but anyway, I'll try to quickly go through this. So first, whenever you see the integral sign like this, it is called definite integral, or informally you can think of it as you're summing up some from the point A to point B along the x-axis. What you are summing up is the quantity, which is f of x. And let's come back to the purple picture here. The fact is that f of x as a quantity, as a number, is exactly the y coordinate of certain point, right? Let's say this point is x naught in the x-axis, and if you look at this point on the curve, this point is gonna be x naught and f of x naught, right? So if you look at it this way, this f of x is essentially the length of this line. And let's change your perspective a little bit. If you try to find the area of this region, and the fact is that you can try to vertically cut along the region one by one vertically. And if you keep cutting like this, you're getting some very thin slices, right? Of course, the leftmost slice is the slice starting from x equals a, and the rightmost slice is the slice ending at x equals b. And I want you to keep cutting. So in that case, the slice, which is vertical, is getting thinner and thinner. And at the end, when you keep going on this process forever, you're actually getting line, right, for each slice. And if you get just a line, it's kind of like you are measuring the length of this line. If I ask you to find the area of the slice, so let me put it this way. So please take a look at that. And to find the area of this picture, you can imagine that after cutting it for so many times and each slice is just so thin, it really looks like a line, which is one-dimensional, right? So essentially speaking, to find the area of the shaded part, it's really like you are summing up the length of each slice, and the slice is starting from x equals a to the slice is ending at x equals b. I want to emphasize that this concept based on integration is essentially the same as summing something. So please keep it in your mind. Please keep it in your mind. And when we learn the volume method later, this concept becomes very important for you to understand how to write the volume formula.